a solid rod of the radius r carries a current of I say I1, which is equal to the 4 amperes into the page with uniform current density. There is also a thin wire at a distance of 2r away from the surface of the rod. Point P is on the line between two at the distance r from the wire. What is the magnitude and direction of the current, which is I2, in thin wire, so that the magnetic field at point P, so magnetic field at point P equals the magnetic field at the center of the rod. Use positive sign for the current into the page, negative for the out of the page. Okay, so let's say that current 1 is into the page and the current 2 is also the into the page. Okay, in that case, we know that the magnetic field that is coming from current 2 at point P will be downwards, right? So I call it B2. Now, whatever is downward, I would say that it's I don't know, negative maybe. So anyway, let's see. So the current 1 will create magnetic field at point P, which is upwards. So I call it this one as a B1. So the magnetic field at point B, so B net at point P, which is equal to the B1 minus B2, because B2 is pointing downwards, is basically equal to the magnetic field at the center of the rod that is coming from current 2. It's a bit tricky, I think, to understand. So anyway, so the current 2 will create in the center of the rod, which is pointing downwards. Okay, so I call it this one as a B2, I don't know, the center of the rod. Okay, so that one is equal to the B2 at the center of the rod. Okay, so let's plug the numbers. The B1 is pointing upwards, so I call it positive. That is coming from the current 2, which will be the mu naught current 1 divided by 2 pi, and the radius is basically 2r, right? If you take these things, it will be 2r. It's 2r distance, so I will put it here 2r. Then negative B2 is pointing downwards, so therefore I call it direction will be downwards, so I put it negative sign, and that one is coming from current 2. It will be a mu naught current 2. So basically we have to find current 2. Okay, I forgot to write it down. Current 2 divided by 2 pi r, because that distance is just r. That one is equal to the magnetic field in the center of the rod, which means it will be it's pointing downwards, right? So the negative mu1 current 2 divided by the so that distance will be 1r, 2r, and 3r, right? So it will be 3r. So it means 2 pi 3r. Okay, so from here we can cancel all 2 pi's. First of all, we can also cancel the r. We can cancel the mu naught. Okay, that means what we'll get it. So we got I1 divided by 2 is equal to the I2 negative divided by 3 plus I2. That's it, right? So you put here 3, you got it. So it will give you 2I2 divided by 3. Okay, so if you want to find I2, which is equal to 3i1 divided by 4. Now if you plug the numbers, you should get that I2 should be equal to the 3 amperes. That's it.